Hey everyone, in this AP Chem series video, we're going to take a look at how to write electron configurations the quick way using the diagonal rule. So first, remember that you can write electron configurations pretty easily if you had one of these things. It's called an Aufbau diagram. So pick any element here, say chlorine with 17 protons, and therefore 17 electrons. You could use this to figure out how all 17 electrons are arranged. Starting at the bottom, you'd put 2 electrons in the 1s orbitals. Side by side, we'll do the handwritten version that would look like 1s superscript 2 for the 2 electrons there. Then simply move up the diagram to 2s2, 2p6, 3s2, that's 12 electrons so far. So to get up to 17, there's just 5 more that have to go into the 3p orbitals. In this video, we'll figure out what to do if you didn't have an Aufbau diagram to follow. So without an Aufbau diagram to follow, my favorite way to do this is with something called the diagonal rule. It's easy to write and all you need is a piece of lined paper and a pen or pencil. First thing we're going to do to set up the diagonal rule is list out each orbital type in each energy level on a different line. Remember to keep it nice and neat, that's why we're using lined paper. So at the top of the lined paper, we'll start with the first energy level, and the only orbital type that it has is the 1s. Beneath that, you'll do the second energy level and all the orbitals in the second energy level. That repeats with a 2s, but then we add a new one each time the second energy level introduces the 2p's. Beneath that is the third energy level, which adds the 3d orbitals. Beneath that is the fourth energy level, which adds the 4f orbitals. Beneath the fourth energy level, you can list out as many as you need. Here I've got it written up to the fifth energy level. Also notice, once I get to my f orbitals, I don't have to worry about adding any new orbital types. There are no atoms big enough to use any orbitals past the f's. So once you get here, you can just keep listing them down for as many energy levels as you need. So here I've got a sixth and a seventh energy level added. And once you've got those listed out, it's time to start drawing the diagonal arrows. So we're going to start at the 1s orbital and draw diagonal arrows through each orbital. And this is the key to the diagonal rule because it's drawing in those arrows that give you the proper electron filling order. Watch me to see how it works. So the first orbital I place electrons to is the 1s because that's the first orbital my arrow passes through. After the 1s, we fill the 2s orbitals. After the 2s, we fill the 2p and then the 3s orbitals. Here's where it really gets helpful. After the 3p orbitals, we fill the 4s's. After the 4s's, then back to the 3ds, then the 4p's, then the 5s's. After the 5s, you'd fill the 4ds, the 5p's, the 6s's. And this arrow following order works as far down as you need it to go. With the diagonal rule, you can never be wrong about which electrons to put in which orbitals. And being able to draw out your own diagonal rule is definitely one of the key ideas for this video. Make sure you've paused and taken a moment to write it down. So let's take a minute and close out the video by practicing using the diagonal rule and writing the electron configuration for a neutral arsenic atom. Arsenic is right here on the periodic table. It's got 33 protons. So if it's neutral, it also has 33 electrons. It's a great idea to pause the video and try this yourself first before watching me. So I've got 33 electrons to assign into orbitals. Following my arrows top to bottom gives me the proper order. The first orbital I add to is the 1s. And since the s orbitals can hold 2 electrons max, I put a superscript of 2. After the 1s, my next arrow tells me to fill electrons into the 2s. So I know to write 2s2. After the 2s, I fill the 2p's, followed by the 3s orbitals. My 2p's can hold 6 total electrons. After that will come the 3s's, which can hold 2. And here's where you really need the diagonal rule, because after the 3s, my arrow tells me first the 3p, then the 4s orbitals. So here's my 3p6, then the 4s's, which can of course hold 2. After those 4s orbitals, we'll fill the 3d's, followed by the 4p's. So here's my 3d, which holds 10 electrons, my 4p's. Now remember, we also only have to get up to 33 electrons. So far I have 2, 4, 10, 12, 18, 20, 30. So that means my p orbitals, which could hold 6, don't have to. They only have to hold 3 electrons to get up to the total of 33. making this my final complete electron configuration for a neutral arsenic atom. That wraps it up for this video. Thanks a lot for watching. Here is a brief summary.